Okay, so in this video, we want to review how to multiply fractions together. So think of a, b, c, d as positive integers, then a over b times c over d is equal to, as a single fraction, ac over bd. And let's think of why this should make perfect sense. So let me rewrite the original expression. And now let's break this down geometrically and see why we then obtain this fraction. So look at the first fraction, and again we will think of starting with a circle. And now we divide the circle into d parts of equal size. Let's consider, say, only one of those parts. So now we have broken down the circle into d parts. So imagine this is one of those d parts, and out of those d parts we take c of them. So we have now c of those in the original fraction. And now when you think of a multiplication, what we're really saying is we want to take a out of b of c out of d. So it means that for every original part that we were taking in c out of d, we're only taking a out of b of this part, and that goes for every other part. So if you think of what this says, it says now, considering one part from the original fraction, we must divide this part into now b parts of equal size, and out of those b new parts, we take a of them. But this goes for every one of the original parts. So if you break it down, what does that mean? We had originally d parts, but now each one is broken down into b parts. That means we have a total number of parts that is b times d. And how many of these smaller parts are we taking? Well, for each of the original parts, we are taking a parts, and there were c original parts. So those a parts will show up c times, which means we have a times c of them. And this is why a over b times c over d is simply ac over bd. Let's look at an example to make this perhaps a little more concrete, where we pick a, b, c, d as actual positive integers. So what if we looked at, say, 2/3 times 4/5? And again, this can be read as we take 2/3 of 4/5. So if we allow the use of this rule first, this will be simply 2 times 4 over 3 times 5. And if we multiply both products, we get 8 out of 15. So if you say, I take 2/3 of 4/5, that's saying I take 8 parts out of a total number of 15 parts. So let's visualize why, again, this should make perfect sense if we view this geometrically, thinking of taking portions, sectors, of a given circle. So let's start with 4 over 5. So if we look at 4 over 5, this means that we begin with a circle. We divide the original circle into 5 parts of equal size. And out of those 5 parts of equal size, we take 4 of them. So this is now 4/5. 4 parts out of a total number of 5 parts. But we don't stop there, because we're only ultimately taking 2/3 of this 4/5. So if you think about this, if you take 2/3 of the whole, Well, the whole being in our case now 4 over 5, so we ignore this part, as we're not taking 1, we're only taking 4 out of the 5 parts. And now we want to take 2/3 of this. Well, if you take 2/3 of these 4 parts, well, the 4 parts have equal size, which means if you take 2/3 of the whole, you must take 2/3 of each individual part. So let me draw this again, and omitting one of the 5 parts. Imagine that this is a perfect copy of this part. So this is our 1, 2, 3, 4. 4 parts out of 5. This is our 4/5. But now we only take again 2/3 of this, which means we take 2/3 of every slice. So we divide now each piece into 3 parts of equal size. And as we've just said, we only take, for each 3 slices, 2 out of those 3. So we're going to take the first 2, say, in each case. That's 2 out of 3 for the first slice, 2 out of 3 for the second slice, 2 out of 3 for the third slice, and 2 out of 3 for the fourth slice. And this is now taking 2/3 of 4/5. But now imagine that you complete the full circle and you add the missing sector here, and you divide it also up into 3 parts of equal size. Let me draw this over here. So now we have the original circle into 5 parts of equal size. Let's divide now each part into 3 parts of equal size. And now we ask, well, how many pieces do we have in total? Well, we had 5 original parts, and we then splitted each one into 3 parts. That, of course, gives us a total of 15 parts, right? 5 times 3 parts for each, total number of 15 parts. And how many do we have out of those 15? We have, well, let's count them. 1, 2, 3, 4, 5, 6, 7, 8. So what we have in the end, by doing 2/3 of 4/5, or 2/3 times 4/5, is nothing but 1, 2, 3, 4, 5, 6, 7, 8, 8 parts out of a total number of 15 parts. And this is why when you multiply fractions together, you can simply multiply the numerators together. 2 times 4 is 8. And the same goes for the denominators. 3 times 5 is 15. And that's it.